Sanibonani Dimalang Absheni. Hello everyone and welcome to Mindset Learn Extra. My name is Pumi. I'm very happy and excited to be with you guys right here on Mindset. It is of course time for us to do our life science today with the Aslam. Hello Aslam, how are you?
How are you doing,
I'm
Pumi?
good, thank you. How are you
I've got
doing?
to teach you one more greeting in that. If I'm standing here, then you have to say Assalamu alaikum.
Oh, Assalamualaikum.
There you go, there you go, there you go.
Good pronunciation.
There
hey?
you go, great,
Great stuff. So what are we doing today?
Today we're doing some yummy stuff. Nutrition
Yay.
for grade 11's, revision for the exams. We're looking at questions, and more questions.
And more questions. Guys, I'm sure that you prepared your glass of water. We are talking about nutrition. You have to keep healthy all the time. And Aslam is really going to be helping us a whole lot more in regards to that. Anyway, guys, we are having this lovely Samsung gadget. I'm sure that you guys have been seeing a lot of posts about it on Facebook. But hey, guys, we already have given away 2 of them. And we have 7 more that we are about to going to be giving away. So make sure that you log on to www.mindset.co.za/learn/win. That is where you can get your winning number, or rather your race number, and then get to fill out a form so that you can participate in this competition. Because really, Aslam, I'd really love to win myself this. It's so beautiful,
you know what?
it's so gorgeous.
I've been waiting 3 weeks now and my name's just not coming up.
Hey, guys, make sure that you really try and make sure that you get this for yourselves by simply entering this lovely Samsung competition that we have for you guys at home. Make sure that you also join us right there on Facebook, where we're going to be answering all of your questions. Bring them through, your comments, your questions, your shout outs. We'd really love to hear from you guys throughout the end of today's show. Right now, guys, let's just learn more and learn extra. Take it away, sir.
Thank you so much, Pumi. What a great introduction.
Thank you.
Welcome, guys. Grade 11s. I'm hoping you are all ready. And like Pumi said earlier, you're taking your water so that water can go down the throat and put whatever is down the esophagus right down into the tummy and help with this hydrolysis so that you can break down the food and do lots of other things with it. Great stuff. Let's hope that you also have started studying. Don't forget. Don't look at the timetable and see that on Monday you write life science, so that from now till Monday you must only learn life science. No. Guys, proper planning prevents poor performance. So you start with proper planning. Get your act together. If you haven't started studying already, if you haven't started, you are in trouble. So to get out of the trouble, you've got to now have 10 hours a day. Now that's hard, but you have to do that. And coming weekend, you've got to push in even more. Half the day, actually 12 hours in that day, in a weekend. You've got to push hard so that you are ready for the coming week and weeks ahead. About 2 weeks, little sacrifices, guys. Small sacrifices, big rewards. So get on with it. Let's start with some multiple choice questions. Most of the questions that we have taken are from the lated paper, the one that they write in June, because the old grade 12's matrics used to do these sections in grade 12 and they were tested. So let's look at it. Question 1. There we go. Question 1. Very good. Screen is stuck. Let's look at the question quickly. Adapted from, there we go, started to move, hopefully. Which one of the following is a function of the liver? It produces hydrochloric acid, it produces a vitamin D, it produces bile. Some funny thing happening here, Pumi.
Okay.
Things are going against us. Okay, there we go, there we go. Let's go to that one, let's go back up then. Okay, now we're talking business. Which one of the following is a function of the liver? Now, guys, how do we answer this question? First and foremost, you need to know your work. If you know the functions of liver, then it becomes easy. If you're not sure about the functions of the liver, then we use the process of elimination. So what does that mean? We need to strike out those things that are definitely not there. They're saying here it produces hydrochloric acid. You know that that's the function of the stomach, so you would have to then take that one out. Okay, we're getting it in different colors here. Oh, there we go. Now we're talking. Right? It produces vitamin D, maybe. It produces bile, maybe. It stores blood and bile. You know your work, you should know that it does not store bile. bile is stored in the gallbladder, so that one goes out. So you're left with these two here. And your correct answer is it produces bile. It produces and secretes bile. Remember, you do not write it produces bile. You simply write 1.1. Normally it will be 1.1.1. And next to that you will write the letter C. Good? The next one says bile in humans. Continuing with that story there. Bile in humans is stored in the liver. Now, obviously, you won't get this question in the exams because the other one would have given this one away. So this one is already out, stored in the liver without even looking at it. So now we're looking at the functions of bile. The last one was talking about the liver functions. Now we're looking at the bile. Emulsifies fat, maybe, cannot be stored. We said earlier it's stored in the gallbladder, so that's definitely out. Converts glucose into glycogen. No, guys, that is the function of the hormone insulin, so that one is out, and you're left with emulsifies fat. Now, I must tell you a story. The story about emulsifying fat. It's very nice, Pumi, to write down. What's the function of bile? It emulsifies fat. You never ask your teacher, but what is emulsifying? But you'll get your mark because you got the right word. But you go your whole life not understanding what emulsify. Now, that was me. When I was in school, I learned this function of bile, and I wrote it right till my college and varsity days. I never ever bothered asking anybody.
Yeah.
And one day, as a teacher in 1993, I was watching Kathy Esty, the one that's also part of Mindset that has been presenting in the past, and she explained what it means. And this is what she did. She said a simple thing. When we talk about emulsifying fat, if this is a fat droplet, drop of oil, for example. When bile combines with this fat droplet, what does it do by emulsifying? It breaks it into tiny little droplets.
Oh.
So let's say it's a butter that you had. The butter is broken out this way. Now imagine the enzyme has to work on this fat now. Initially the enzyme could work there, behind the screen and in front of the screen. Now because we got so many small little droplets, the enzyme is working there, all over the enzyme. So we have increased the surface area for the action of the enzymes. And that is what emulsifies fat means.
So it doesn't dissolve, it just breaks it.
It breaks it down into smaller
pieces.
particles.
Okay.
And then the enzyme will then deal with it further. Good, Pumi? We've learned something today, right?
Yeah, hey.
Which one of the following carbohydrates is stored in the mammalian muscle and liver? Carbohydrates, right, first of all. And now, we got glucose, we got starch, we got sucrose, we got glycogen. Okay? Number one, glucose is a monosaccharide. It cannot be stored because it's soluble in water. It's going to dissolve in water and you're going to use it up. No good. Starch, maybe. It's a polysaccharide. It's insoluble in water, so it may work. Sucrose is a disaccharide, the sugar that you put in your tea. When you put in the tea, what happens to it? It dissolves. So it's soluble in water, so it won't work. Glycogen, yes, it is a polysaccharide as well. And the correct answer is glycogen. Both, by the way, starch is a polysaccharide. By the way, if we want to even look at that, this is a monosaccharide. This is a disaccharide. Simple sugar, double sugar, many small monomers making up these polysaccharides. Starch is the polysaccharide that is stored in plants, so that one is out, and your correct answer is D, glycogen. Good. Let's move on. Now we come to section B type of questions, again from 2010. This one from Nathan again. Now here, guys, classic type of nutrition question. They give you the diagram of the digestive system or the alimentary canal or a part or parts of it, and they're going to ask you questions. So they say, study the diagram of the part of the human digestive system and answer the questions that follow. Straightforward, normal instruction. So there's a diagram there. They're giving you the diagram there. They've got the letters A right through to F that is there. And we need to now identify B, C, D, and F. Our first question is to identify those things there. So let's start without looking at the story there. Let's label on here. A, you got it? That's it. That's the liver. I'm hoping. You got to check. You got to give the answer before I give it. And if I give the answer and you're right, you say yay, and you are happy. Make sure that your parents are listening to you, that you know your work. And if it's not, you're going to say nay. And you're going to be sad about it, all right? So keep that up as you're going along. They didn't ask you for A, by the way, so we actually have to say, nay, Aslam, you're answering the wrong question. No marks for you, 0. They didn't ask you for A, they asked you for B. But we're on the diagram, so we do all. B is the gallbladder. I didn't give you a chance to answer. Sorry, guys. Let's move on anyway. C. C. I can't hear you. Okay, yeah, I got it there. Esophagus. Esophagus. D. That one is easy. Stomach. Yeah. Stomach. Stomach. Okay. E. That's a tight one here. Look, where is it? Where is it coming from? It's coming, this organ would have been there. Coming there, and this tube would have been coming from that organ to the duodenum. So it would be part of the pancreatic duct. Pancreatic duct. Just watch where the label lines are, and that. Remember, they don't have to show you the pancreas there, but you should know that the pancreas is in this area. And lastly, F is this first part of the small intestine, but because there are no other labels, you can get away by saying small intestine. If there were other labels, for example, this one had a label, and then this one had another one, and the last part, then you would have had to label them duodenum, jejunum, and ileum in their order. Okay? Good. All right, let's see what we've done so far. B, C, D, F. B is the gallbladder, yes. Esophagus is C, D is the stomach, and F, I told you, small intestine or duodenum, because it's the first part of the small intestine. 2.2, give the name of the digestive juice that flows through part E. Through part E, and there now, that's why it's so important that you labeled E correctly. If you labeled E incorrectly, if that was the wrong duct, then obviously you would have had this answer wrong. And because it's the pancreatic duct, then we would have, obviously, the pancreatic juice coming out of there. Yeah? Good. So the pancreas secretes pancreatic juice. This pancreatic juice goes into the duct. From that duct, pancreatic duct, it goes into the duodenum eventually. Notice that because the pancreas is now secreting a juice into a duct, and the duct is transporting the juice away, we say that the pancreas, at this stage is known as an exocrine gland. A gland that secretes its secretions in a duct or a tube is known as an exocrine gland. At the same time, the pancreas also acts as an endocrine gland when it secretes the hormones insulin and glucagon. More about that later. These hormones don't go into a duct, they go directly into the blood. So an endocrine gland is a ductless gland. It doesn't secrete its secretions in a duct, it secretes it directly into the blood, from the blood to all parts of the body. So pancreas is endocrine, and this is a famous old-time question. Why is a pancreas referred to as endocrine and exocrine gland? You must be able to explain that. So there's your pancreatic juice coming there. State one function of part A with regard to nutrition. Part A is the liver. Now obviously you need to know your functions there. One of those functions you would have already got from the multiple choice. It wouldn't happen in an exam paper. In the multiple choice it said there that it produces bile. So that's one of the functions of the liver in terms of, and they didn't say all the functions of the liver. They said in relation to nutrition. Good? And those functions are, it forms bile or produces bile or secretes bile. It converts glucose to glycogen. In fact, the liver itself doesn't do that. The actual story there is that glucose is converted to glycogen in the liver. Let's just correct that. In the liver. Okay, because the function of that liver is not to do that. The function of the hormone insulin is to do that. And vice versa, huh? Both ways. It also stores glycogen. That is the function of the liver. It breaks down amino acids, deamination. Look at this word. Interesting word, deamination. Deamination. So in other words, removing the amino group, which is NH2. Removing this part from an amino acid. You take it out. And this is then gone to the excretion. It will go to the kidney. Right. Go to the kidney. From the kidney, it will be excreted Good. Sharp. It detoxifies poison substance. In other words, your blood goes to the liver. In the liver, if there are any poisons in that blood, the liver functions to remove those poisons. Okay? It also synthesizes vitamins A, D, E, and K, and B12. Okay? So those are the functions of the liver as such. Predict the effect of removing part B from a person. What is part B? Part B is the gallbladder. Now, what is the purpose of the gallbladder? It stores and releases bile. Now, if bile is not released from the gallbladder, and if it's not stored, it may get directly released. You may well say, look, the liver may give it straight to the intestines. But if it's not there and it doesn't release it, then obviously fat digestion will be hampered. Your fat digestion would be hampered in that way. And the last question, provide the pH of part D. Part D is the stomach. The pH is plus minus 2. Okay? And the next part of the question says, why is this important? The enzymes that work in the stomach prefer the pH 2, and therefore, if it wasn't pH 2 in the stomach, then those enzymes would not work. Guys, we've finished one whole question in this. I'm sure you earned a good break, so let's get back after this break. Refresh yourself, post the question so we can answer it.
Welcome back from the break, guys. We are still learning life science right here on Mindset Learn Extra. And yes, I just prepared myself another glass of water, which is very important while you are busy studying. We are definitely going through nutrition with Aslam today. Aslam, take it away.
Thank you so much, Pumi. Good. Guys, the last question, just a little bit background in the last question before we took the break. It was provide the pH of part D was the stomach, and we said that the pH is plus minus 2. And the question was state why this pH is important here. Because the enzymes in the stomach prefer an acidic medium. Now, we have to understand this pH story. Remember, pH is from 0 to 14, with 7 being in the middle, being neutral. And anything below 7 is acidic. The further away you from 7, the more acidic it is. The closer you are, the more neutral it is. And anything above 7 is a base. The closer to 7 is a weaker base. And further away from 7 is a strong base. So this is important to know what's happening there. That's number one, the background. And lastly, your work from grade 10 says that enzymes are specific to pH. And as you have learned your sections in nutrition, you would have learned that in the mouth, it's slightly more or less neutral, we would say. Some textbooks say slightly acidic, but it's more towards the neutral side, you know. And if you go into the stomach, then it goes to 2, the pH. And when you go into the small intestine, then the pH is 9, 10, 11. So it's alkaline. So different enzymes have different pHs. So therefore, they will function best in those areas. So the enzymes that came from the mouth in the saliva into the stomach would stop working once the pH drops, because the low pH would denature that enzyme. But the stomach enzymes, they work good in a pH of 2, so they will function properly in that environment. Okay? Denature, by the way, just to go back again, means it will change the shape of the enzyme. And if you remember, you spoke about the enzyme works on a lock and key hypothesis. You know, if you break the key or if you melt parts of the key, that key won't open the lock that it was intended to open. Therefore, if you denature the enzyme, you're changing its shape. And if you're changing its shape, it would not be able to work with the substrate that it was intended to work. So that's what we're talking about there. So get that into your head. Also, remember, guys, understand all the time. Understand the work. Don't just swallow the work and try to vomit it out later. Good. Still in the diagrams there, another diagram, study diagram below, taken from the same paper, by the way, and answer the questions that follow. Here's an interesting diagram movement of food in the alimentary canal towards the stomach. So if it's moving towards the stomach, and you can see clearly it's not the mouth, then between the mouth and the stomach, which is the organ that we find there? We find the esophagus there. And they're showing you the movement there. They're telling you something is B and something is A there. Identify the process shown in the diagram. If it's in the esophagus and the food is going down, and you can look at the wave-like motions there, obvious you have to say that this is peristalsis. Provide labels for parts A and B. You saw the diagram. A, you see here, because of the line, the label line being there, it could talk, the learner may say, this is the esophagus, to give the mark. But if you look at the label is not just showing to this diagram as such, but it's showing you the two layers there. Sorry, the two layers. There and there, those two layers there. So the actual label would be the muscle layers. Or if you spoke about the circular and radial muscles that are found there. The smooth, or you could have said smooth muscle that is found in the esophagus. Remember, smooth muscle is involuntary and they contract and relax without your knowledge, and therefore they push the food down. Very much like toothpaste. When you press at the bottom, the toothpaste comes out in the front. Now look at what's happening here. The squeezing is taking place here, pressing the toothpaste. Here, the toothpaste then is actually moving in this direction. And then behind that, it will squeeze again, and it will move further and behind. This is what's happening. Contraction, relaxation, right through the alimentary canal to move the food down. Okay, and B is obviously the food, or it's already called a bolus. So after you've chewed the food and pushed it down, swallowed the food is actually called a bolus. Explain one way in which the part of the alimentary canal diagram is structurally suited. I've given away some of that already earlier. First of all, it is made up of muscles. Which type of muscles? Smooth muscles, which are able to contract and relax to push the food around. It also has goblet cells. Along the length, it has goblet cells in this area here on the inner wall. Let's get some color there. In the inner walls there, you can get goblet cells. And if you go back to grade 10, goblet cells are epithelial cells, columnar epithelial cells, which take a glandular function in a secretory function. And goblet cells secrete mucus. Mucus, which will, where are we? There. Mucus to reduce friction. In other words, when the food is now going through, you don't get friction taking place there, because friction is going to damage the passage. That is why I said earlier also, you've got to have water. You've got to have water. The water also helps to reduce friction when you're swallowing and when peristalsis takes place. Still on diagrams, still from the same question paper. Study the diagrams below and then answer the questions that follow. There they give you some fancy schmancy diagrams there, and they're asking you some questions. Through which part of the alimentary canal is the section represented by diagram 1 made? Okay? They want to know this diagram here, where is it made? Where is it made? And that would be the small intestine. Provide labels for A, C, and D on the diagram now. A, C, and D. That's A. C is there. Okay. On the top of these cells here, you will have microvilli. In other words, the epithelial cell is like that, and then it has these thing happening there. Okay. A, obvious, we spoke about this just now, the muscle, the smooth muscle. And what was the last one? D, A, C, and D. Yeah. D, this big cell here in the middle would be a goblet cell. Okay. The muscle wall, microvilli, goblet cell. Yay, I get 3 out of 3. Explain 3 ways in which the part represented by diagram 2 is structurally suited for its function. What is diagram 2? Let's look at it. This is diagram 2 here. Diagram 2 is the villus. Don't confuse microvilli with villus. This is a villus, and the villus is made up of columnar epithelial cells there, and these columnar epithelial cells have microvilli. Okay? They want to know how is this thing suited for its function. Suitability for the function means what does it have to make it good to do the job that it has to do. Okay? So you've got to marry structure with function. It has this to do that. First of all, you know that these villi, there are many villi in the small intestine, okay? And they are very small structures. They have thin walls. They are richly supplied with blood vessels. They have a lacteal. The columnar epithelial cells have goblet cells. The columnar epithelial cells also have microvilli. Those are some of the structure parts. Now let's look at why are those structure parts so important. Now we're going to look at how we marry the structure to the function. Right? We said it has a lacteal. Why? To absorb digested fat and absorb and transport digested fat. It has lots of blood capillaries to absorb and transport digested proteins and carbohydrates. In other words, the amino acids and the monosaccharides are also absorbed there. What happens, what we are saying, guys, in the small intestine, all these small things are small things. These small units are found, the glucose, amino acids, etc. They're in the digestive system, where inside, if we go back in our diagram, somewhere in this region here, and the villi are all in this area here, on the walls of the small intestine. So that's where we are. That's how you've got to actually understand the context of what we're talking about. So it has the blood capillaries that will absorb these proteins and carbohydrates. Not proteins itself, the small units of protein, which is amino acids, and the monosaccharides. It is elongated. You can see this in a diagram. It is elongated and folded. Anything in life science, anything in your body that is folded, is not folded to look nice. It is folded to increase the surface area. If it was straight, if this thing was straight just across here, it would have been just this big. Now, because it is folded, if we stretch this out, it's going to go like that, you see. We have to measure, it can go longer than that. Can you see the difference? So it increased the surface area. Right? It is surrounded by thin wall, right? Thin wall, not thin wall, thin wall epithelium to facilitate absorption. If something was thick, if there was a thick wall, then it would have been hard for substances to move across, because it's a single layer. In fact, even better than thin wall, you say a single layer of cells that facilitate absorption of food. The epithelial cells have microvilli, which further increase the surface area. The epithelial cells have goblet cells, which secrete a mucus. Okay, so there's many that you could have mentioned there. We only needed a few. Which letter represents the blood vessel that transports the end products of fat digestion? Which vessel is that? We mentioned it earlier. The lacteal. So we need to look at a diagram. Where is the lacteal? It would be this one in the middle here. So that is F. And your answer there would be F. Where will there be a higher concentration of glucose, at X or Y? We need to know where's X and where's Y. Can we see X and Y? Yeah. Here's Y. It's showing you this vessel here. Oops. Y is this vessel here. X is this vessel here. The arrow is showing you that the blood is moving in this direction. So if the blood is coming in here, and we're saying that the glucose, etc., they're going to go in there, then obviously there would be more at Y. The answer is Y. Why is that so? Because the blood that's entering the villus is deprived of glucose, etc. Not deprived completely, but it'll have less. And as it's going through there, all the glucose that is diffusing into the villus will come into the blood vessel. So by the time it leaves, and from there, remember, the venule moves out from there to unite, the venules unite to form the hepatic portal vein, which takes all these substances, these digestive substances, to the liver, where it will be processed, and from there it will go to the heart, and from the heart to all parts of the body. Good. Okay. We're going to give this one. All right. No, let's not do that. Okay. Study the diagram of the human alimentary canal below. Now, a different way of asking the same question. There's a diagram there, and they want to know from you, give the letter of one structure involved in each of the following functions. Mastication. Mastication can only take place in the mouth. By the way, an easier word for that is chewing.
Chewing.
Huh? Ah, there we go.
Chewing,
There you
yeah.
on the ball there. So that would be A, the mouth. Prevents choking. That would be the epiglottis, which would be H. There you have it. The epiglottis that's covering the esophagus, so that when you the trachea, it's covering the trachea. So if you are eating and swallowing, then the trachea is kept closed with the epiglottis, that little cap of the trachea. Okay, that's why they say you mustn't talk or laugh, etc., while you're eating, because then the body thinks you're breathing, and the flap opens up, the food goes in the wrong pipe. Peristalsis. Peristalsis, really speaking, it could be many of these things. The first one would be B, but it could be more than that as well. Remember that. There's it B, C, D, and E, all of those things. Secretes hydrochloric acid would be the stomach, and that label would be C. Secretes intestinal juice will be the small intestine, and that would be E. There is the small intestine there. Remember, this is the large intestine here, right? And this is the small intestine in there, in that area there. Good. And state three functions of part label G. Part label G is the liver. We've done that already, so we're just going to open it up just to see. We're not going to look at that again. Explain two adaptation of structure E for the absorption of food. Structure E is the small intestine, and notice how this answer overlaps with the other one. For a start, the whole small intestine is long, so it increases, and thereafter you go with the villi. And all the stories that we've spoken about the villi in the last question, it is applicable here. The thin, the many, the folded, the microvilli, the goblet cells, etc., etc., etc. Guys, that covers us with two whole questions now. So I think you have earned yourself a break. To me. Pumi.
Yes.
To me.
Oh, yes, guys. Let me just say hello to Mabuya Million, Romaria Singh, Andrew Mabuna, Tulu, Prudence, Brada. Those are the people, those are the mindsetters that are watching the show. And I can see a whole lot of you are really watching the show because of the questions that you've posted. Remember that you can always post all of your questions that you have for us, and then we are willing to answer all of them. We'll see you shortly after this. Welcome back, mindsetters, from that break. I'm loving the questions that you guys are asking on the Facebook page. I have to agree, though, with Ebuka Victor. I'm saying that I wish I did life science. It is so interesting. Thanks to Aslam, he's making it very easy. So, Aslam, one another mindsetter would like to know, Walter K. Sutola is asking, what is the villi's function?
Walter, are you listening to us, guy? You're listening to us. Okay, if you looked at how we spoke about the suitability of the villus, what was that question all about? It's telling you that it has this to do that. So if you look at the whole question itself, the villus itself is the absorptive surface in humans. In other words, although the intestine is the small intestine is where the food is absorbed, but where is it absorbed? It's absorbed at the villi or the villus. But there are many thousands of villi in the small intestine. So the main function of the villus is to absorb the products of digestion. And after you've done, see, it starts with digestion. You first put the food in your mouth, you chew it, so there's some mechanical digestion, and your juices get involved, and you break down the carbohydrates smaller, the protein smaller, the fat smaller, go to the stomach, you mix it up, lacquer there in the stomach with hydrochloric acid and some enzymes, you break it down further, plus the stomach is turning upside down and moving all around. Okay. And with that, the food is going to hit each other, going to break down. They get into the small intestine, where final digestion takes place. The enzymes now break it down to the smallest. It can't break down smaller than that. Now it is soluble. And in the soluble state, it diffuses into the villus. What's waiting for it there? the transport system.
Oh.
The villus has a lacteal and it has blood capillaries. So this digested food gets into those things, and from there they join the main circulatory system. So it goes to the heart, from the heart, well, liver first, then from there to the heart, from the heart to all parts of the body. So in other words, you're eating this food first, it's in the alimentary canal. You can't use it, your skin cells can't use it, your muscles can't use it, because it's not in the blood, it's in the alimentary canal, the gut, as we call it. From there it must go out into the blood. From the blood it must go for processing in the liver. Once it's being transported, we don't call it absorption anymore, we call it transport. Why? Because it's being transported. When it moves from the alimentary canal into the villus, that is absorption. And the way that proteins are absorbed is different from how carbohydrates are absorbed. And these two are both different to how fats are absorbed. Okay? That's the function of the villus. Next question.
Another question is coming from Debuhonewo Mahwaba, asking, what causes the pH in the stomach to be more or less 2? Is it the gust?
I think she got cut off. We were looking at that one together earlier. Eh?
Oh, yeah.
I think she was going to say gastric
and
juice.
The gastric, okay.
Yeah,
okay.
not the gastric juice. Teboho, no?
It's Teboho.
Teboho, yeah. Teboho, it's not the gastric juice that causes the pH to drop. It is the hydrochloric acid that is secreted by the stomach that brings the pH down to 2. Notice hydrochloric what? Hydrochloric acid. And an acid has a low pH. So the hydrochloric acid is what's bringing the pH down. Guys, this is what we want more of, your questions, because your questions talks to what you are not understanding.
Absolutely.
And that, the answer to that must make you understand. You are at point A, you want to be at point B. As we're explaining, you must be somewhere in between. In fact, you must even go beyond point B if you can. Next question.
What is a chyme?
Chyme or chyme, however you want to call it, chyme. Once the food has been mixed with saliva and it's made into a ball, we call it a bolus. This bolus then gets into the stomach. Once the food is digested in the stomach and it mixes with hydrochloric acid, etc., and when it leaves the stomach, that part of the food is now not called food, it's called chyme, because it's food mixed with digestive juices and acid, etc., leaving the small intestine, leaving the stomach into the small intestine. That is called chyme. Is that it?
Yep.
Good, guys. And some of you wanted to know the answers for question 2.4 and 2.5. So we were talking about the gallbladder here. Huh? We're saying what happens if we remove it. Now notice that the gallbladder is connected to a duct. The liver is not connected to that duct. So the liver will produce bile. We'll have bile. But there won't be anywhere from the liver. Remember, it goes into the... sorry about that. Let's just undo that. One more time. Okay. Not helping me. There we go. So from there, the bile will go into the gallbladder. The gallbladder then releases those things all the time. So either one of two things. You could have answered, if you were smart enough, you could have said, look at this duct here. Look at this duct here. From the liver, it can go directly still into the intestine. It can happen. Somebody may argue that. But then we wouldn't be able to store bile when we need it. That means it's going to be secreted all the time. Could be wasteful. That's the other problem. Bile is only released into the intestine when it's needed. Or we can go the other way. There's going to be too much bile in the small intestine. Can you see that this question is a little bit wide open? It can go either way. But for our studies, let's assume that the only way that the bile could get to the small intestine is via the gallbladder. Then that means the small intestine will not get bile. And if the small intestine does not get bile, this would affect how fats are digested. Because the fat was first broken up by bile and thereafter. And another function of bile, which we haven't mentioned yet, is the fact that bile neutralizes the acid from the stomach. So when the food is coming from the stomach into the small intestine, the bile has a higher pH. So it helps, it's one of the agents that helps to neutralize that. So the pH also would be affected. So we can go much further. And if we have a doctor here, more importantly, a specialist, gastroenterologist, right? One that deals with the digestive system specifically, could go into volumes in this answer, but we worried about at your level. At your level, this is what we are talking about. One, you look at the, why is this question put there? It wants to question whether you know the functions of bile, or the gallbladder in this case. So whatever the gallbladder was supposed to do won't happen. That's how we answer that question. Okay, and the last one, provide the pH of part D 2.5 was 2. We've agreed that, and we've also said just now that hydrochloric acid produces this or reduces the pH there. More importantly, the question wants to know, why is it important? Because enzymes that work in the stomach prefer an acidic medium. Okay, let's move on then with where we stopped. So that goes back to those things there, and let's move on. A learner ate a peanut butter sandwich at 8 o'clock. The amounts of various nutrients found in the mouth, stomach, small intestine, and times at which these amounts were determined are tabulated. You have all that with you in front of you. And we need to do that. But you need to read that, and then you look at the table and see what's happening. All these are the nutrients. Nutrients in the, which organ? The mouth, the stomach, the small intestine. At 8 o'clock when they ate the food, what happened? This is what we found. Notice there's no amino acids there. There's little fat. There's some protein, there's some glucose, and some starch. When we went further into the stomach, we find that the starch is decreasing as we're going there, and the glucose is increasing as we're going in that direction. Proteins, they are decreasing as we're moving in that direction. Amino acids, there was nothing, and all of a sudden we have quite a bit there. Fat, there was 5 grams in the stomach, we had 5 grams. In the small intestine, we have 1 gram. So something has happened to the fat as we moved in this digestive system. How much starch was present in the small intestine at 10 o'clock? Now, guys, all you need to do here is look at the table. 10 o'clock, I'll say, starch, there's it. And where? In the small intestine, there's 10 o'clock. So your answer should be 2 grams. Generally, in life science, you must always put the unit there, because sometimes they give you a mark for your answer and a mark for the unit. If you leave out the unit, you're going to lose 1 mark. And if you give your unit, and if they're giving a mark for unit, even if your answer is incorrect, if you had 5 there or 15 or whatever, you would still get the mark for the unit as long as you put grams there. Okay? 6.2, explain why the amount of starch decreased during movement through the alimentary canal while the amount of glucose increased. You ate starch. What is starch? Starch is a polysaccharide. What did you do in your mouth? You broke down the polysaccharide to a disaccharide. And as you went down, what happened? You broke down that disaccharide to a monosaccharide. What is a monosaccharide example? Glucose. So obviously, if you are digesting the starch, as you're going down, there'll be less of the starch. And what are you digesting it to? You're digesting it to glucose eventually. So obviously, also, the glucose level will go up. Starch is digested into glucose. I've just given you more information there. Fats are not digested in the stomach, but rather in the small intestine. Give evidence from the table to support the statement. How nice. What is the evidence in the table? That tells us that fat has not been digested in the mouth, it hasn't been digested in the stomach, but only in the small intestine. You don't need to be a rocket scientist to answer that, because we started with 5 grams, we still have 5 grams there. So therefore, that means none of the fat that was taken in has been digested. But oops, when we come to the small intestine, what has happened? It's gone to 1 gram. So there, some digestion has taken place. Good. I'm not going to discuss the answer again. We've done it already. Right? Name the 2 end products of fat digestion, and that would be obviously fatty acids and glycerol. Fat is made up of 3 molecules of fatty acids and 1 glycerol. Or if you want to get into the heavy science stuff, we're going to talk about propanetriol, propanol 1, 2, 3, etc., etc. Organic chemistry if you want to go into. But at your level, you don't have to know all of that. You just simply say they're made up of fatty acids and glycerol. Those that do science, however, you would know that because you're studying organic chemistry at the same time. How many grams of protein were digested between 8 o'clock and 10 o'clock? Show all your calculations. Simple. You look at protein. There was 30 grams when we started. At the end, there was only 10 grams. So you must work it out. That is, again, arithmetic, not even maths literacy, not even mathematics, but arithmetic, simple arithmetic. 30 grams when we started, 10 grams when we ended. So 30 minus 10 is 20 grams. Notice we're keeping the units as we're going along as well. So that's a data response type of question. They're looking at the nutrients, they're telling you what's happening, and some questions. They could even ask you to make graphs in what's happening here. Line graphs of one of those would be interesting to see how it decreases or how it increases. You could do that as well. And another type of data response, again, question 7. The table below shows the details of a meal eaten by a grade 12 learner. So they're giving you the meal, sausage, whatever they've had there, fried potato chips, what's the nutrients there, beans, fruit pie, ice cream, whatever the child has eaten, and they want to say, identify the food type which gave the learner the following: the most protein. Which column are we going to look at? Carbohydrate. No, definitely not. You say that, we bong you out. It has to be this column here, and that is the protein column. And which one gave him the most? It would be beans. Most protein would be beans. All right. The least fat. Again, now we don't look at the others, we look at fat. We go down the line. The least is 1. That's the one that we are looking at. The least is 1. And where do we get 1? Beans again. Beans is the lucky winner. Eat lots of beans. There's less fat and more proteins in there. Leguminous plants. Eh? Identify the food type that is best suited to prevent scurvy. You need to know your work there. You've got to look at the table, and you've got to look at your vitamin C content. It would be fried potatoes. Vitamin C prevents scurvy, right? That is why, in the old days, lots of people used to get scurvy when they were traveling on the ships, because they couldn't store much fresh fruit and vegetables. Today, it's not such a big deal because they can store it and they can eat it along the journey. Give a reason for your answer. All right, I've given you part of that answer already, and that is, has the highest most amount of vitamin C. Which food type has the least overall nutritional value? And that would be ice cream, unfortunately, Pumi. So there's no for the ice cream. It doesn't have much nutritional value compared to the others. You've got a lot of carbohydrates, you've got a lot of sugar, and you've got quite a bit of fat, but nothing else, no vitamins, etc. in there, unless they start putting in some of that in some of the ice creams. Okay, you're going to get some nuts in ice cream. It may help in that way as well. All right, here's another one there. The total the total energy value of this meal is 5,000 kilojoules. In one day, this learner requires a total of 15,000 kilojoules energy. Calculate the proportion or percentage of the daily energy that this meal provides to the learner. We're telling you that a child needs 15,000 kilojoules. And he's only taken 5,000 kilojoules. It's like telling you, the test was out of 40, you got 16. What was your percentage? Same story there, okay? So they want to know their proportion or percentage in that way there. So you work it out very much the same way. That 5,000 over 15,000 times 100, it'll give you either 1/3. Well, it's easy to work it this way. It's 1/3. That's 33.3%. 33.33%. Good? Name 2 food types on the table that provide the most energy for the learner. You got a table, we're not going to waste time. Fried potato chips and a fruit pie. Explain what could happen if this learner regularly ate food containing more than 15,000. So he only requires 15,000 kilojoules. If he eats more than that, what's going to happen to that? That's an easy question, and it's a topical issue that in America and Britain, many children at your age and younger suffer from this condition, and that would be that the body cannot use this food, so it will be converted to fat, leading to malnutrition, but the specific type of malnutrition would be obesity. And that would be the gain of mass, and cholesterol levels will go high, and this will cause the narrowing of the tubes, which will lead to high blood pressure, hypertension, and obviously cardiovascular diseases, diseases of the blood system and the heart, vascular, the blood system. Name one source of roughage in the above meal. Now, what is roughage? Roughage is substances that your body does not have enzymes to break down further. So they simply enjoy the ride in your digestive system. But by doing so, they stimulate the extension of the muscular walls, stimulating the secretions of all the enzymes and the juices and so on. So they keep bulk in the system roughage. One source of roughage in this meal would be beans, fruit pie, fried potato chips. There would be some roughage in there. Name 2 functions of roughage. I just gave that to you just now. That is, adds bulk to the waste material, causes colon to stretch. That's right at the end. It stimulates peristalsis of the entire digestive system, absorbs and retains water. Roughage tends to keep the water, and the water is there, it keeps moist, and therefore it's easy for it to go through. And this can prevent constipation. You know, for me, constipation is the thief of time, okay? And diarrhea waits for no one.
Oh, yeah.
Okay? And it prevents hemorrhoids. You're not a specialist, you wouldn't know. Hemorrhoids is piles, bleeding from the anal area. Prevents absorption of poisonous substances. It prevents cancer of the colon. So good to eat your veggies. Cleans the intestine, lowers cholesterol level. It also gives you a feeling of fullness. Why? Because that part is not getting digested, and if it's not getting digested, it's staying in your system until it goes out. And just going to go to the essay question quickly. All right, there we go. This is a type of an essay that you can get. Write an essay on the chemical digestion, or I'm just putting there digest. I put the ones in brackets to tell you that it could be just any digestion, or it could be chemical digestion. And I put the slashes, they can ask you for protein, carbohydrate, or fat in the human body. Refer to the parts of the element, the digestive juices and the enzymes that are involved. So you need to say from the mouth, this is what happens: mechanical, chemical. Esophagus, down, stomach, chemical, mechanical, intestine, and so on. You're going to explain each one as it goes along. Guys, I'm hoping that helped you with this section on nutrition. Hand you over to Pumi, who will take you out.
Oh, yes, guys. Thank you so much for watching the show. But hey, before I get to end the show, quickly, Aslam,
Yeah.
Linda Hulumen would like to know what happens in the long run to the stomach of a person who chews gum frequently.
Frequent gum, don't listen to anybody, nothing happens to your stomach. That chappies, if you got time when you're in the toilet, look down in a pan, especially when you're number 2, you'll see the chappies there. It's not going to do anything to your stomach. Don't listen to that myth. There's nothing wrong with chewing chappies and swallowing it. I've swallowed chappies as long as I'm living.
Okay. All right then, guys. Thank you so much for watching the show. We'll see you next time. And hello to Joanna. Bye-bye, guys. Thank you for watching.